Okay, so today's notes are pretty short, and we're going to look at two new functions, and I think they're pretty cool functions. They're very different than what we've looked at so far. The first type of function is a step function, and I'm just reading at the top of the page. It says step functions are another type of function that is related to the linear family, and you'll see why. And its graph will reflect its well-chosen name. The example: in many states, a sales tax is added to most goods that you buy. The tax rate, or your percent, varies from state to state. Let's suppose that your particular state issues a sales tax on any goods purchased. You are selling candy bars, and the taxable amounts and tax imposed up to $1 are shown below. Now there is a typo within the first bullet. It actually shouldn't state between. It should state the language that's used below. So greater than 1 cent and less than or equal to 20 cents. The tax is 1 cent. Okay? So if you buy a candy bar, okay, so if you're buying it, so it's going to cost you something. So greater than your 1 cent, and actually we have to include the 1 cent. So greater than, let's say, 0 cent. So you're going to buy something. So let's change that to just be greater than 0. So no matter the cost, you just have to spend something. But less than or equal to, okay, 20 cents, the tax is going to be 1 cent. Greater than 20 cents and less than or equal to 40 cents, the tax is 2 cents. And then the third bullet, greater than or equal to 40 cents, but less than or equal to 60 cents, the tax is 3 cents. And then if you spend 60 cents or less than or equal to 80 cents on a candy bar, you're going to spend 40 cents or 4 cents. But then last, greater than the 80 cents and less than or equal to $1 on your candy bar, the tax is going to be 5 cents. So we're going to complete the graph for this situation. So I just want to highlight our axes of our graph. Your taxable amount is the x-axis, which is your cost of your candy bar. Okay, and then you have the amount of tax that you're going to pay on the candy bar. So if you're looking at it in terms of coordinates, this is the cost of the candy bar for x, and then your y is the tax on your candy bar. And then if you have highlighters, you're going to want to use them here. I think it's neat to draw the graph in color. Okay, with both of these axes, our units are in terms of dollars. Okay, so let's graph the first bullet. So graphing the first bullet, I'm going to do that in orange. So this one right here. So greater than 0 cents, this is the cost of our candy bar. So for x, greater than 0 and less than or equal to 20 cents, we're going to spend 1 cent in tax. So that's the first y value right here. So greater than 0 for the cost of our candy bar, that'd be an open circle, and less than or equal to 20 cents, so this would be a closed circle, and anything between, you're going to spend 1 cent on tax. The next bullet, we'll grab green, greater than 20 cents, and less than or equal to 40 cents, the tax is 2 cents. So that's our next amount of tax. Greater than 20, so we're not spending 20 cents, we're going to spend 21 cents. And less than or equal to 40 cents, any amount in between, that we're going to pay 2 cents in sales tax. So you see the gap or the step that's forming? In pink, Actually, let's do this light blue. I'll graph this third bullet. Greater than 40 cents. We're going to spend 3 cents, so that's that next Y value. Greater than 40 cents, so open circle, and less than or equal to 60 cents, close circle. We're going to spend 3 cents in sales tax. The next one, to spend 4 cents in tax, okay, we have to do greater than 60, but less than or equal to 80. So I'll do that in red. So to be charged 4 cents in tax, we have to spend greater than 60, but less than or equal to 80. And then last, I'll do that in pink since it's already highlighted, greater than 80 cents, okay, but less than or equal to $1, we're going to pay 5 cents. So greater than 80, less than or equal to $1. And there's our step function. Notice in the graph, so if I look at, grab yellow here, notice this section right here. Every time we have a closed circle, there's an open circle above it. Okay, we don't have, for example, 2 closed circles or 2 open circles. And that's the case all the way through. So for this 20 cents in candy bar, if you look, so 20 cents as an X value, you're going to pay 1 cent in tax. We're not paying the 2 cents in tax because that's the open circle. So let's take a look at the questions at the bottom. Okay. First question. Using the graph, how much will you pay for a candy bar that costs 80 cents? So 80 cents on the x-axis, you look up, and you have your 2 circles. You have this one here and that one, but since this one's open, this here is your answer, and you're going to pay your 4 cents in tax. You can look at it as a point, so 0.80 for x, you're going to have a y value of 0.04. So the answer, and make sure you include your unit, is 4 cents in tax. Number 2, a candy bar costs 55 cents. What's the total cost? So 55 is right here between 50 and 60. You go up, and here we are. So we're going to spend 3 cents in tax. Oh, we want the total cost with tax. So that was just the tax. So excuse me. We have to add in the amount of the candy bar. So plus 0.55. A total cost with tax is going to be, for an answer, 58 cents. And then last, someone purchased 4 candy bars at 55 cents a piece. They gave you $2.25, so together they gave you $2.25. Is this enough money to cover your candy bars? So we just figured out that they're 58 cents a piece with tax times 4 candy bars. That's a total cost of $2.32. So the answer, okay, is it enough? No. And the explanation part is it will cost $2.32, and they only gave you $2.25. All right, last function is the piecewise function, and its name is also very fitting. So if we take a look at the top, it says a piecewise function is a function whose formula changes depending on which input values, and your input values are your domain. are being used. So based on the domain, if we just look at the x-axis, so right here, down to -1, less than -1, we've got the line. On the x-axis, okay, between -1 and 2, we've got this curve. And then for values from here over, we have this line. However, we can't have for each function 2 y values that go with an x if it's going to be a function. So that's why we have the open circle, closed circle when they're lined up. Only one can be open and one of them closed. Okay? So we're going to graph the following function on the grid. Before I do that, one thing to highlight is the 3 functions that made the piecewise to the right. This one's a linear, so this is really y equals x plus 3. Next one's quadratic, because it's degree 2, so y equals x squared. And the last one is just y equals 3. So that's why it's a horizontal line. So we have 2 linear, and then one's quadratic. All right, so we're going to graph a linear function. So we're going to graph p of x equals 3/2 x minus 4. And then p of x equals x minus 5 squared minus 3. And we graph them according to the domains that are given. So for the linear, we have to use x values from -2 to 4. So you can go to your calculator, and we're looking for x values of -2, -3, or I'm sorry, we're counting up. So -1, 0, 1, 2, 3, and 4. And those values are, if you just want to listen, -2, -7, -1, -5.5, 0, -4, 1, -2.5, 2 is -1, 3.5, and 4 is 2. Now with a line, you could just plot the first and last point and then just connect it with your ruler. So left 2, down 1, 2, 3, 4, 5, 6, 7. Now, so you need to determine if it's open or closed, because it doesn't have the equal to line right here, that's going to be an open circle. So an open circle for that point, and you can make note of that on your graph, and then the closed circle for an x value of 4. So 4, 2, 1, 2, 3, 4, 1, 2, that's closed. And then take your straight edge to connect. Okay, so we want to label. So that was p of x equals 3/2 x minus 4. Now the other function is for all values greater than 4. But you want to include on your table the value when x is 4, so that's where you put your open circle. So I'm just going to do 5, 6, 7, 8. So the point would be 4, -2. 5, -3, 6, -2, 7, 1, and 8, 6. So open circle at 4, -2. So they're aligned and they can't be both closed. And then 5, -3, 6, -2, 7, 1, and 8, 1, 2, 3, 4, 5, 6. So we're going to connect. We're also going to put an arrow, because it just said all values greater than 4. So it's not a dot at both ends. So here's p of x equals x minus 5 squared minus 3. Now find the value of p of 4. So that wants to know what is y when x is 4. So going over your table, graph 1, 2, 3, 4, here's an x value of 4. You look up, you've got a closed circle and an open circle. You want to look at that point where it's closed. So it's 4, 2. So p of 4 equals 2. Now we're going to do 2 times p of 0 plus p of 7. So we have to find p of 0 first and p of 7. So p of 0, when x is 0, that's right here. We look down, we've got the point 0, -4. So p of 0 is -4. And then p of 7. So 4, 5, 6, 7. We look up and we have this point right here, which is 7, 1. So p of 7 is 1. So substituting those values in, we have 2 times negative 4, which gives us a negative 8, plus 1, which is negative 7. And then last one, which of the following describes the graph shown below? Well, we have part of a line and part of a degree 2. So if you look at your linear part of each, one says 2x plus 2, and the other one says 1/2 x plus 2. If you look at 2 points on your line, say this point and this point, we have a slope of up 1 over 2. So up 1 over 2 is a slope of 1/2. That gets rid of choices 1 and 3. And then you need to look where you're shading because they have a different set of inputs or domain. This one is x greater than or equal to 1, which would be shaded on the right side of negative 1, and less than or equal to negative 1 is on the left. And since at negative 1, we're shading to the left, it means it's going to be choice, this one's out, which automatically brings us to choice 4. But let's just talk about the quadratic before we stop. So at x greater than 1 or negative 1, so there's the open circle, and then it's shading, again, greater than, it's to the right side, and it does have the arrow. It doesn't stop, so 4, yes, is the correct answer.